The rise of AI and the importance of data to modern business has driven us to recognize that data matters, not just storage. This episode of the Tech Field Day podcast focuses on AI data infrastructure and features Camberley Bates, Andy Banta, David Klee, and myself, Stephen Foskett, before our AI data infrastructure field day event this week. Welcome to the Tech Field Day podcast, where we bring together a group of IT technical experts to discuss a single idea about key concepts in our industry. This podcast features a wide variety of perspectives from members of the Tech Field Day delegate community and is recorded today in association with our event this week, AI Data Infrastructure Field Day. Tech Field Day is part of the Futurum Group, and this podcast is also published on our sister company's site, TechStrong TV. On this episode, we're digging into the concept of data infrastructure and suggesting that data infrastructure isn't just storage, it's something a lot more than that. But before we begin, let's meet who's on the podcast today.
Hi, my name is David Klee. I am the founder of Heraflex Technologies, and I spend my days focusing on SQL Server performance tuning and everything underneath it.
Hey, I'm Andy Banta. I am the storage janitor from all over the place. And I'm here because I've been working on data infrastructure for a large part of my life.
Hi, and I'm Camberley Bates. I am an analyst with the Futurum Group, and I have been focusing on data infrastructure and data storage and data protection and data security now for too long. We won't go into that.
Excellent. And I am Stephen Foskett, organizer of the Tech Field Day events. And yes, I also consider myself to be a storage nerd. But I reflect on the fact that really storage doesn't matter, data matters, right, Camberley?
Mm-hmm. Absolutely. So a couple of years ago, I started talking about this as data infrastructure as opposed to data storage. And part of that is because half the storage vendors didn't want to be associated with storage. Something was like icky or dirty about it. I'm not sure what the problem was. So we just started calling it data infrastructure, and they seem to be happier about it. And then we've got the AI stuff popping up, and all of a sudden we're having this odd merging piece of it. Is like, we have these these data manager kind of folks that we knew for data warehousing, and the data storage people, and the data pipeline, and all that kind of stuff. So it's gotten kind of pretty blurry, Stephen, and that's kind of why we're talking about this. And the poor guys that are having to make sure that things keep on moving and the performance is there, well, that's who we're trying to talk to.
Yeah, and I understand why people aren't interested in talking about storage, because nobody really actually wants to think about storage anymore. Storage is just something that's there where you have resources and you can use it if you need it and not use it if you don't need it. And I do think that data infrastructure might be a better catch-all than storage for what this idea is. But I think at the same time, it's the data infrastructure or storage has always varied depending on what uses what things you're using it for, what the workload is, whether you're doing research or whether you're a consumer business or that type of thing. So I think that the whole idea of data infrastructure all of a sudden being different for AI that's the way it always has been.
I have a bit of a different take on it. I agree with you all completely. I would love to see it expanded a little more to understand more of the enabler storage. You don't buy storage just to have storage. You buy storage to put data of particular types on. It could be mixed general purpose. It could be machine learning models. It could be large databases. It could be anything you want. I would love to see the AI portion of all of this expand more into how it's being used so that you understand why it's being used. And if you understand why it's being used, you can manage the whole thing smarter, more efficiently.
I feel like in many ways, AI is driving us to the conclusion that we've been making for a long time. In other words, we've always known that storage didn't matter. We've always known that it was, writing data to be able to retrieve it later is never, it's an element of a stack, but it's never been an application. That's really not a thing. What you're doing with that data is the important thing. And we've even in the storage industry always known that there was sort of horses for courses when it came to storage system architecture, when it came to interfaces and access methods and things like that. But AI has really driven this point home in a way that other applications didn't. If you look at cloud, most cloud systems use just regular old file system storage. They kind of don't care. AI really does care, just like databases and data lakes and data warehouses really did care. And I think that it's really forcing us to kind of come face to face with this truth that storage doesn't matter, data matters. At least that's how I look at it.
I'm kind of looking at it as a layer cake, and I think a lot of the people that are developing and bringing systems out are looking at the layer cake. The bottom layer is the drives, the networking pieces of within the, how you're networking your systems, what you're using in terms of the ASICs or custom hardware that's being down there, the DPU kind of pieces of it. But even then, I mean, it's like what's in that hardware matters. I was just with one of the vendors this last week and talking about, they're not using DPUs because they're using an Intel processor that has got a data reduction assist in there. So they don't need to use a DPU. So even in the hardware piece of it, there's some highly customized items that are doing this, just not off the shelf for a lot of the vendors. The next piece of it has to do with the protocols piece that you just talked about, whether you're file, block, object, or whatever. And that does matter based upon the AI. The piece on top of that is the data services, with the traditional data services that we're looking at, which is all the replication and those items that are going on, and then adding more into has to do with all the cybersecurity things that they're bringing in. And then the next thing on top of that seems to be for AI is more of the data classification that we've been trying to get people to do for years and years and years. But when it comes to AI, all of a sudden this thing becomes super important, because I have to be able to do the items about identifying all that metadata, to be able to figure that information out, what I need, hide the privacy information, to be able to drop it into my vector database. And we're even now starting to see the data infrastructure vendors bringing vector databases into that stack, which completely changes what they're delivering on. It's no longer just those other layers that are below, but it's gotten bigger and taller.
Well, those would be largely the data services, as you mentioned, that fit on top of the data infrastructure. And I think the demands that's make of data infrastructure would be potentially some of the things we see out of AI, which would be the much higher amount of storage, or much higher amount of storage that's needed, and much faster bandwidth to the storage that's needed. And these can allow some of the data services that you just mentioned to work much faster. At the far end of the spectrum, though, there's still the AI is generating huge amounts of data that you need to end up somewhere as well. And a couple of weeks ago at SDC, I went to a talk by IBM about talking about tape systems for AI. It's it's like the data infrastructure spectrum really hasn't changed that much, other than just the raw amount that's needed and the speed, the access to some of the data that's in more demand. And I think you're correct that the data infrastructure companies are providing more of these data services to make these things more available, and probably working on getting their data infrastructure to handle this fairly well. One other aspect that I want to throw into this mix that I am going to be very interested in hearing from our vendors in the next few days on is power consumption is a huge issue, especially not necessarily in the U.S. as much as it is all over the world. It should be more of an issue here, but unfortunately it's not.
Well, that's another issue I think that AI has given rise to, and that's, as we've talked about at AI Field Day and a lot of other events, because the AI hardware is so ridiculously expensive and capital consuming, it is important to make sure that you're optimizing these systems more than previous systems. So essentially, it's incredibly important for storage to be very, very fast, very reliable, low power, low heat dissipation, et cetera, because every ounce of all of those things is going to get slurped up by these GPUs and these advanced, offload processors. And those things are so much more expensive and so much more valuable and mission critical than the storage, that companies, we talked about Solidigm, we've talked about this with them, that it's driving sales of more advanced storage. I mean, I remember talking about this with some of the other kind of scale out storage companies as well. One of them in particularly privately confided to me that although they're a leader in AI data infrastructure, they're not even an afterthought when it comes to speccing out these systems, because their systems are so cheap relative to the cost of an AI supercomputer that essentially it's all about specs and it's not about price anymore, which is a wild situation to be in, because the enterprise storage world has always been so incredibly driven by cost, and it's so incredibly profitable. They're really sidelined because of the cost of the rest of these solutions. And that's shocking.
I am surprised to hear that, because we're also, the flip side of that, Stephen, is that a couple good friends that are doing quite a bit of work in helping these clients, actually consume their GPUs that they spent a lot of money on, are also now going through the process of looking at what they need to store all this data on to support the GPUs. And the few of them are getting sticker shock. So wherever that sticker shock is, so I mean, maybe it's not the millions, hundreds of millions of dollars the GPU is. So maybe that's the issue here, is where the balance of that first transaction is. But as this other side has happened, they're going through and saying, wait a second, how are we going to do this? How are you going to really? And I think that's why IBM was talking about tape, because it's cheap, right? It's very cheap to keep, and it's also power efficient to do that. So it's kind of an interesting space to be in.
Yeah, this was specifically in relation to one of those mega projects where they were buying, literally billions of dollars of hardware. And in that context, the storage wasn't that big of a line item.
And that could be very, very, yeah, I can see that, definitely can see that. And I think that's probably true if I look at a supercomputer, that the storage is often not that big thing. The supercomputer is usually it's the network and the servers that are is really the costly piece of it.
That'd be a fascinating breakdown to look at scale of these deployments and then watch the graphs shift as the scale of it grows.
And in terms of cooling and power as well, it's interesting to think about the impact of networking and storage on power consumption in the data center. We heard about that at AI Field Day from Infabrica, and I've certainly heard that from storage companies as well, to the point that essentially they cannot use disk drives, not from a performance, well, certainly from a performance perspective, but mainly from a power and cooling and perspective. Essentially, they need that space for GPUs.
And they're so they're moving away from the hard drives, which supposedly consumes more power. And there's arguments on that out there as well. So I'm not going to get into the arguments and everything. Then the solid state, which reasonably doesn't consume as much power because just kind of the design of it, and you're not having to keep them spinning in order to free up power for the GPUs and the servers and that kind of stuff. So yes, we're definitely seeing some of that process happen. It's kind of like throwing a lot of things up in the air, trying to figure out how I'm going to architect for it.
A lot of it goes back to metadata management. It goes back to your point earlier. How much of this data can we destage onto something like tape and get it off to the side, stop paying for the expensive storage, and then how quickly do you need to retrieve it based on what you're doing with it?
I think that a lot of that's going to depend upon what the use case in the application is, because there is this discussion of certain use cases that you're going to keep retrieving that data and teeing it up to retrain and retrain and retrain. There is also the use case of which I think they're calling RAG, or they are calling RAG, in which you're taking new data, and constantly bringing in new data and training it. So maybe that is completely training on top of the current one that's been engine that has been trained. But there is a constant flow of data that's going through this pipeline in order to keep things moving and current and accurate. and what it's producing on the other side of the house.
And as this happens, I mean, there are not an awful lot of intermediate results that you probably need to keep track of in some way, bits and pieces that you don't necessarily need to make reference to right away, but that you might want to make reference to at some point, and that can certainly be some of the deep archival type things that could be pushed off the tape or could be put on spinning media. And this is another hot topic with me in AI is that there needs to be some auditability in the way AI processors are done, and keeping these records of how we got to where we are today is a necessary step.
It's interesting too. One of the things I heard from a company that was implementing model training was what you just mentioned, that there needs to be traceability in terms of the exact components that were used for the model, but also that preparing data for training was a huge user of storage capacity and storage performance and storage features. Essentially, they needed to collect and move and organize data to prepare it to be used in training. And that was something that was taking them a lot of time and resources as well.
It's metadata management. Well, and I'm wondering if it's even more than that, because you're getting into, well, metadata management is classification. You're getting into the privacy of the information, being able to protect any information that's, black it out. So when I'm looking at a record, I'm looking at just the information that I'm allowed to have access to, and some of that access management. But I absolutely agree with you, Andy. It's like the traceability becomes really critical, because we will see those rules go through probably in Europe first, and then over California, and then trickle across the United States, the way it seems to happen. But for being able to say, okay, so this is how I came up. And I think about it, if we start using AI for risk management, for any kind of decision that impacts somebody's financial environment, their health environment, any decisions that are made in that person, there's always opening up for liability. That means that you're going to have the traceability and the information, just like we do with the HIPAA and SEC 17.4.a, et cetera.
And this is straying off data infrastructure at this point, but that is sort of the point that I look at here, where it's if you're counting on the answers you're getting, you need to demonstrate that those answers are based on valid knowledge. And this goes into, you need somewhere to store this traceability, and this is not necessarily going to be the wide, fast storage that the GPUs and the CPUs and the engines that are actually doing the AI processing are going to need, but you will need these along the way as well. So I think you talked about the multiple layers stacking up of the data services. I think the multiple breadth of layers as well, where you have everywhere from tape up to the newest, best high bandwidth memory is important as well. And if we're going to be talking about data infrastructure this way, I also think that we need to sort of keep in mind the concept has blurred between what is considered storage data infrastructure and what is considered memory data infrastructure. These layers are just continuing to pile up, and the distinction between which is memory and which is storage are getting fuzzy.
Isn't that based upon really persistence, or why would we and I'm not arguing here at all against that, but why would you merge something that's not persistent with something that is persistent?
Well, and lots of times things are worked on in non-persistent ways that are immediately flush to a persistent way, simply because you can't get the bandwidth to a persistent way immediately. Mm-hmm. But the layers still pretty much stack up that way.
Mm-hmm. Yeah.
And with the advent of CXL and the advent of networked CXL, you're going to end up with the idea that you have an awful lot of the storage networking problems you had over the past 20 years, 30 years, are going to start showing up with memory.
Definitely true. And Another thing I'd like to bring up too that we're going to hear about at AI Data Infrastructure Field Day is the various protocols that can be used to interface these things with AI systems. So we heard from Elastic at AI Field Day about vector database interfaces for RAG applications. I know that we're going to hear a lot of talk about object storage from MinIO. We're going to hear a lot about other storage methods, in terms of supporting NVIDIA superclusters and so on. What's your take on database versus storage versus object and so on?
Well, this is a question that again came up at the Storage Developer Conference a couple weeks ago, where there were about 40 variables that were thrown up on the screen talking about automotive data systems, and they brought this to a point of saying that power consumption is one of the biggest concerns with automotive data systems. And if you approach it this way, some of this becomes rather, some of it, if you're basing it entirely on power consumption, object storage becomes a very obvious choice, where you're not delivering blocks if all you need are bytes, and you can deliver large objects as a single object rather than having to do multiple operations to get those objects. So, but that's just one factor, and there's a variety of different factors depending on what your use is. That's why we have so many different storage protocols today.
Yeah, short answer is yes.
Yes. It's a dessert topping and a floor wax.
So we've hit a lot of topics here, everything from literally the physical media being used to the importance of metadata and storage services, protocols, databases. What's your summary here? What makes data infrastructure more than storage? And Camberley, let's start with you, since this was really your area of expertise.
Well, it's because we need to understand what's inside of the data more so than we did ever before. We need to be able to do that in order to track how we're training something to do something. Whereas before, we were making the decision because we were presented with the data. Maybe we dug in to say, how did we get to that decision? But now we're turning this thing potentially over to something that will be making some, not necessarily decisions, but hard recommendations and making action items. So that data and how that data is trained and how that data goes forward becomes really critical. And the other piece of it is that we've spread our data across the world, and needing to manage to that, where that data resides, et cetera, is part of also that piece of that geopolitical, who owns what information, et cetera.
And I see data infrastructure being different from storage in largely the ways you talk about, that there are data services, there are the concepts of metadata that you need to pay attention to. But I'm going to throw in the cynical comment that we talk about data infrastructure rather than storage, because storage companies don't want to talk about storage.
I completely agree with all of that. The way I look at it, data infrastructure versus traditional storage. Traditional storage is the what and where. Data infrastructure adds the why, and potentially even when.
Interesting. Yeah, that's very much true, and that really is the difference between storage and data. I mean, it's the what and the why more than it is anything else. And I think that we in the storage industry have been keenly aware of this question for a long time, and now we're finally really facing it with the advent of AI. So thank you all so much for joining us, not just here on the Tech Field Day podcast, but as well at AI Data Infrastructure Field Day, which is happening. If you're listening to this on October 1st, it's happening tomorrow. Please do tune in at techfieldday.com. Before we go, tell us a little bit more. Where can we connect with you and continue this conversation?
Yeah, you can find more out at davidklee.net or heraflux.com. And I am definitely looking forward to the next couple of days.
Yes, and I'll certainly be available all of AI Data Infrastructure Field Day. You can find me on Twitter, on Blue Sky, both as Andy Banta. I'm on LinkedIn, and my blog is andybanta.substack.com.
Stephen, thank you. Looking forward to AI Field Day, or AIDI Field Day, which is a chunk of words. You can definitely find me at the Fraternal Group website, and Infrastructure Matters is my podcast. And we'll see you there.
Great. And as for me, you'll see me here on the Tech Field Day podcast, as well as most Tuesdays on the TechStrong Gang, and of course at our various Field Day events. So thank you for listening to this episode of the Tech Field Day podcast. If you enjoyed this discussion, please do subscribe. You'll find us on YouTube as well as your favorite podcast application so you don't miss an episode. And also, please do give us a rating or review. We'd love to hear from you. This podcast is brought to you by Tech Field Day, home for IT experts from across the enterprise, part of the Futurum Group. For upcoming events and more episodes, head over to techfieldday.com/podcast or view us on TechStrong TV. Thanks for listening, and we will catch you at AI Data Infrastructure Field Day and another episode of the podcast next week.